Hello, everyone. So today I'm going to talk about a problem called detect cycle. So we have a graph and we're going to try to find if there is a graph, there is a cycle in that graph. So if you're interested in knowing about the best resources to learn algorithms to get into a big tech company, I tell in a video in the description below the best resources that I use to get inside of Microsoft that will save you time and headaches. You don't have to go through like 1,000 problems. So I'll tell you the best problems you can work on to be prepared. So without further ado, let's take a look at the problem detect a graph, a cycle in a graph. So a graph, the idea is you have nodes. So the circles are nodes. You have a value inside of each node, and then you have edges. So this is a directed graph, meaning you have an arrow from one node to the other node. The undirected graph, you don't have an arrow pointing in one direction. It's just like a straight line, meaning you have a connection both ways. So the program you're gonna create today is gonna check if there is a cycle there. So as I'm saying in the previous videos, you need to learn the patterns. So the pattern we're gonna learn today it's called topological sorting. So we're gonna see a bunch of problems. I'll be posting a problem called course schedule 1, and we also have course schedule 2 that use the same template. But I want you guys to memorize this template. So when you're in an interview, you don't have to like, oh, how do I do this? It's already in your mind. You can think about how to tweak some small details in your code, but you don't need to learn from scratch, like come up with the algorithm from scratch. I think having algorithms memorized in your head in an interview, it's a great way to save up time and be efficient. So how do we create a graph node in Python? So we have a constructor. That constructor will have the value and an array of edges. So for example, in the problem, in the graph we had before, so let me share the screen. So in that graph here, let me share. 2 is connected to 3 and 4. So on the edges array of vertex 2, that will be connected to both 3 and 4. So that's what we do here. So we create 0, 1, 2, 3, 4, and A is connected to 2. 0 is connected to 1. 1 is connected to 2. 3 is connected to both. 2 is connected to both 3 and 4. 3 is connected to 0. 4 is connected to 3. So it's exactly the picture of that graph we had before. And then we create a function called loop graphs that's going to iterate through every single node. It's going to check if that node has not been visited already. And if it hasn't been checked already, we're going to call hasCycle, which will tell us if a cycle has been detected. So why do we need a loop inside of when we're exploring the graph? For example, if we look at that graph we had before, if we look at that graph, that first search is gonna check every single node. And so we would only need to call for this graph only once the function hasCycle, and it would give us the answer. However, if I have a disjoint graph, so a disjoint set graph is a graph like this one. So if I call that first search on 1, it's gonna explore 2, 3, and 4, but we still have to check 5 and 6. So when we do that for loop, we make sure that we're visiting all the graphs inside of that program. So going back to our program, let's put a debugger. So we will put a debugger on here. on the loop graphs function, we are going to loop. Let's step in. So the first node we're going to start with is 0, right? So that's the very first node. So we're going to call the function has cycle, and now we're going to add that to the visiting array. So we always have two sets, visiting and visited. If we are looping through the graph and we see that we are going through a node that we are currently visiting, it means we have a cycle. So that's how we check if there is a cycle. If we check a graph, a node has already been visited, we say true, that graph has a cycle. So now we're going to explore all the neighbors of 0, starting probably with 1. So now our node is 1. We add that to visiting. Now we are going to 2. We add that to visiting. Now we go to 3. We also add that to visiting. And finally now we're back to node 0. But node 0 is on visiting. So if we look here, we have 2 and 0. So 0 is a node that we are currently visiting. So that means we have a cycle. So that will return true, meaning we do have a cycle, and that's gonna start popping the stack recursively, and that will return true, meaning we do have a cycle. So this template here is what we call a topological sort algorithm. So I really recommend you guys memorize this because a lot of problems are solved the same way. I'm gonna post the solution to course schedule 1 and course schedule 2. They follow the same idea. So memorize that, play with the debugger. That will be very useful. So I hope you guys enjoyed, and see you in the next video.